everybody, we are moving on to lesson 2.7, points, slope, forms. Go ahead, get out your notes, your notebook, pencil, something to write with, and follow along. So this is what point slope form is. Y minus y1 equals m times x minus x1. Sorry about that. So it's y minus y1 equals m times x minus x1, where m is your slope. Just like always, we use m for slope. And x1 and y1 are a point on your graph. So they are an ordered pair. X1, Y1 are an ordered pair. So notice that we are subtracting the X1 and the Y1. So that would be if they were positive numbers, you would subtract the two of them. If they're negative, we will go through some examples of what that's going to look like. So our first one says to write the equation of the line in point slope form that goes through the points 2, 3, and 4, -1. So I need to start by actually finding my slope because they didn't give that to me. So let's go ahead. Let's label our x1, y1, and our x2, y2, so that I can use my slope formula to find what the slope actually would be. We know that slope formula is y2 minus y1 over x2 minus x1. -1 minus 3 would give us -4, and -4 over 2 would give us -2. So my slope is -2. So let's go ahead and use this to fill in to our formula. We have y minus y1, and in this case, that is 3, equals m, we just solved for, -2, times x minus x1, which is 2. So this one, using our first point, would be y minus 3 equals -2 times x minus 2. And notice I just said that's if we were to use the first point, right? So that is one. But I might get the question, well, what about the other point? Is it wrong if I use that? Absolutely not. I can also use the other point. So let's show what that would look like. Y minus y1. In this case, it's a -1. So that would be written as minus -1 equals m, -2, times x minus x1, which is 4. So I could use that second point, but see I had that negative in there. So what happens if I'm subtracting a negative? This becomes addition, right? So it's actually y, my class kit can be a little touchy when I scroll up and down. Y plus 1 equals -2 times x minus 4. And that would be your second one. So it does not matter which point you use. It is just important that you keep track if you do have a negative and if you subtract that, what that's going to look like. All right. So now it wants me to graph the following line. So let's first identify the pieces that we know. I know that this is my slope. So I have my slope as -2 over 3. And then I know my x1, y1. So that would be x1 and that would be y1. Remember, though, if I am subtracting a negative, that's when it becomes addition, right? This tells me just to subtract the point. So if my x is adding 4, that actually means that that started off as a -4. And my y is subtracting 3, that meant that that was a +3, right? We just showed that in the last problem. If I were to put these into the formula, y minus 3 equals x minus -4, and that's why it becomes addition, okay? So let's start by graphing our -4, 3. So I go back 4, up 3, graph that. And then I use my slope. My rise is -2, so I'm actually going to go down 1, 2, and to the right 3. And I'm just going to continue that pattern down 1, 2, into the right 3. 1, 2, 3. Until I have, a few points on my graph that I can now put a line through. And that should be what my line looks like for this graph. So that's how we graph from point slope form. We identify the point, we identify the slope, and we place them on the graph. All right, the next thing it says is to find the slope of each of the following graphs. So I'm going to zoom in quite a bit here so I can actually count the slopes of these graphs. So this one looks like I'm going to choose this point right here. I'm going up 1, 2. So I go up 2, and I only go over 1. So that slope is 2 over 1 for the dotted line. 2 over 1 just simplifies to 2, right? And let's go ahead and zoom in and look at the solid line. I'll do that in a different color. So let's say I'm right here. I go up 1, 2, and I go over 1. So that one's also 2 over 1, okay? So my dotted line is also 2. Oh, that does not look like a 2 there. Okay, let's go ahead over here and look at our solid line. 1, 2 over 1. Okay, so that's 2. That's the solid. And the dotted is going down, so I know that's going to be negative. Let's look. It goes down 1 and over 2. So that's a down 1, right 2. So that's a negative 1 over 2. So what do I notice about these two graphs? Well, these ones, the first one, they have the same slope and the lines never touch. Second one, they have different slopes. Not only are they different, but they are opposite reciprocals, and these graphs intersect. So our first set of lines, I would say those are parallel. My second set of lines, I would say those are perpendicular. They're perpendicular because they do create right angles, right? Where they cross does create a right angle. So the slopes of parallel lines are the same, right? We had 2 and 2. They never touch. The slopes of perpendicular lines are opposite. One was positive and one was negative. And they are reciprocals, which basically means the fraction flips upside down. So if you had 3 over 4, the perpendicular slope would be negative 4 over 3. So that just means we flip the fraction upside down. Parallel slopes are the same. So if I had 2, my other slope would also be 2. Okay. So let's write an equation with a parallel slope. So what I'm going to do is I'm going to circle that this is supposed to be parallel, and I'm going to find out what the original slope was, because I know that parallel means that they're going to stay the same. So if the original slope was negative 1/6, the slope is going to stay negative 1 over 6. And then I have my point, 3, negative 5. So I have x1, y1, and we're going to put that into the equation. Y minus y1, which was negative 5, equals m, negative 1 over 6, times x minus x1, which in this case is 3. There is one thing I have to change before I can be done, which is this minus a negative. So it should be y plus 5 is equal to negative 1 over 6 times x minus 3. And if you're okay with adding that addition in from the start instead of rewriting it twice, by all means, go for it. I'm just going to continue to show it so we do not forget. Our next slide is taking a second to load. Here we go. Okay, so we are now going to write one that is perpendicular. So I know that that's going to be an opposite reciprocal. My original slope is negative 6 over 7. My new slope is going to be positive, and I'm going to flip it over. So it's going to be 7 over 6. And again, I have x1, y1, and let's put it in our equation. Y minus negative 2 equals m, 7 over 6, times x minus, in this case, negative 5. Okay, from there, we have to change our minus a negative, right? So I'm going to have y plus 2 equals 7 over 6 times x plus 5. And there is my perpendicular line. That is it for today. So that is writing in point slope form, right? Make sure that we're being careful of our negatives. Minus a negative, we change to addition. If you're given a graph, there's a lot of different possibilities to write from point slope form because you could pick any point on the line. The slope should always be the same though. There are some other rules with parallel and perpendicular. Remember, parallel is same, perpendicular is opposite reciprocal. That is it for today's lesson. Make sure if you have any questions that you reach out to your teacher.